One of the major considerations about Aircaster technology and use in factory settings is the flooring conditions. While we'd love for all of our customers to have a beautiful epoxy floor like the one you see here, it's not very realistic. While our air bearings love to float on epoxy, and I'll talk about that in a little bit, most of our customers are realistically using this on machine trowel finish concrete, and all of our air bearing ratings are designed for that purpose. This is a more common machine trowel finish surface that you'll find in our industrial customer base. Be careful about competitors of ours giving you ratings for Aircasters that are all based on beautiful, perfect epoxy floors, because it's simply not realistic in the world we work in. Also be careful of customers who are not willing to meet our floor specification for an Aircaster application. This is an example of a floor that would not comply with our Aircaster technology for proper use. As you can see, this floor is an aged concrete floor that has large cracks in it, abrasion, steps, porousness, and it's very rough and textured. Next, we're going to talk about Aircaster technology as it's primarily used in our air skid applications. One of the misconceptions is that the load is generally resting on the Aircaster, which is smashed against the ground, and that's not true. What actually happens is the load is actually resting on the steel frame on what we refer to as rest pads, which is this area of the skid unit, which is transferring the load directly to the ground. One of the great things about doing this is using Aircasters over wheels is when you're in a deflated condition, you have no safety issues with your load accidentally moving away. It's literally resting steel on concrete. Now, once it's in this position, as you can see, the Aircaster is actually elevated above the ground, and so the question becomes, how does an Aircaster begin to perform? Well, the first thing we do is we introduce into the Aircaster, we introduce airflow from outside, and it begins to fill this inner cavity of the Aircaster. As the air continues to fill this chamber, as you can see, the Aircaster begins to extend downward, coming in contact with the floor, and when it does so, it self-seals against the floor. As that seal begins to happen and pressure builds, this air frame, these rest pads, begins to lift off the ground. So as the air begins to build pressure inside this unit, as you can see, the rest pads begin to leave the ground. Generally speaking, as we fill this chamber, the air begins to leak into here, and what we're trying to achieve is about 36 psi at the maximum rated load for a given bearing. That's our normal operating condition. Now, we do make bearings that operate at higher loading conditions, 60, 65 psi. Those are called high pressure bearings, and they're for specialty applications. But most of our general Aircasters are rated to perform at 36 psi, and this is critical because an Aircaster is designed to be a compliant device. And in a minute, we're going to talk about different flooring conditions and why that compliancy is important. If we were to put the PSI up higher, the Aircaster begins to get more rigid. And as it gets more rigid, it becomes less compliant. And as it becomes less compliant, it cannot handle different flooring conditions that are normal in factory settings. But back to our air skid. Here we go, building air. Our frame begins to lift, the load begins to lift off the ground. We're approaching 36 psi, and as we do so, we're starting to put a lot of pressure against the perimeter, and the air is wanting to begin to escape from the perimeter. So as the air begins to fill this chamber and the pressure internally exceeds the load weight, we actually begin to lose air outside of the seal, and this creates what is known as air film, which is the lubrication required to float over a surface. While we're operating at about 36 psi, generally our air film is only about 4 millimeters tall. And this is critical again when we get into this compliancy discussion and talking about the different types of flooring conditions. Compliancy remains one of our greatest assets in achieving proper movement of a load. If you have an epoxy floor like the one we showed here in this training room, it's a beautifully finished, very smooth surface. It's similar to the air hockey table type concept. Under that scenario, you can have a more rigid bearing, and it will allow for compliancy because there's not much movement in the floor. If you were to take a microscope and blow up the flooring conditions, smooth epoxy might look very much like this, or a machine finish surface like a milling center would put on something. It's very smooth, and it has very little resistance to an Aircaster moving over it. That is considered an ideal situation. However, most of our customers have something that looks more like this, which is machine trowel finished concrete. If you were to blow that up, it would look like lots of ridges. And the key to machine trowel finished concrete's performance is the fact that the ridges are not very high. The best way to think about this is as a mountain range, or more importantly, in a mountain range, the valleys that you find in a mountain range. So as an air caster is trying to move over a surface like this, what's happening is in the valley itself, you're losing air film and you're losing airflow. And so the greater the valley, the more air film you lose. If you were to take epoxy and put sand grit in it and blow it up, it would look something like this. And you can imagine as this air caster is trying to float over the surface, not only is it dragging on the peaks, but one of the reasons it's dragging so hard is because the valley is so large that you're losing all of your air film, which is the lubrication it takes and requires it to have the frictionless type movement that we experience. This valley, the bigger it gets, the more air film, to the point where you'll simply just stop and not be able to move. Aged concrete with old pitted concrete, while it may have started out looking like this nice machine trowel finished concrete, over time it gets more aged, more pitting in it, it gets more valleys, which creates more drag. And drag is what begins to stop air bearings from having proper air film movement and lubrication. Ideally, and what we base all of our designs around, is machine trowel finished concrete. Machine trowel finished concrete is what's most uniformly found within factories, and it's relatively easy to maintain. Where we have trouble with some of our competitors and lose opportunities is when people base all of their technology and all of their ratings on smooth epoxy. And what happens over time is the customer begins to get very frustrated because they're not able to maintain in a factory setting that smooth finish. And if the bearing is operating its maximum capacity under the best flooring condition possible, you can see as that begins to degrade that you'll have nothing but problems, and you'll begin to have more increasing valleys and more increasing air loss to the point where you simply cannot move in an effective manner. As we've discussed, flooring surface is a critical function. Machine trowel finished concrete is our desired objective, or epoxy finished floor. One of the other things that does arise though has to do with expansion joints and steps in the concrete. And while an air caster designed by Airfloat can handle a certain amount of expansion joint width and a certain amount of step, there is a limitation to it. Example of what I'm talking about here is shown in this drawing, where you have concrete where at an expansion joint a piece is heaved up, and the step I'm referring to is this item right here. Now, one of the things that helps us get across the step, as you remember, is we have a primary communication hole here, but we also have what we refer to as sheet crossing holes. So as that air caster moves and impacts that step, what happens here as the air, it will start to deform, and you'll start to lose air film. Now, you're still maintaining air film back here, but as the bearing progresses and gets on the other side of this unit further, at some point we have the sheet crossing hole is here and starts to put air lubrication on this side of the step, and it allows it to continue to cross. However, as I said earlier, the larger the step, the more problematic, and at a certain point you'll be so disruptive to the air film that it will not be able to cross the step. The same thing applies to an expansion joint. If the expansion joint is relatively tight, a simple saw cut, generally our air casters are designed to transfer across that, and as the unit crosses over and gets on this side, we get the communication hole for the sheet crossing on this side of the expansion joint. It moves the air film lubrication to the other side, and you're fine. However, if this expansion joint were to get very large, it's possible that as we begin to cross this unit, we get so disruptive here that we lose so much air film out of the expansion joint that it simply cannot move any longer. One of the simple fixes for this is on an expansion joint is just fill it with simple epoxy. If you take simple epoxy, which they make expansion joint epoxy, you can fill it in and it'll cross the epoxy no problem. That's what I recommend for more permanent situations where you're running air casters continually. However, if you just have a limited move, a one-time move, it can be as simple as just taking a piece of tape and putting a piece of tape over the expansion joint and just simply floating across the piece of tape. That's obviously not recommended for continual operation, but in limited moves, that's fine. Now, related to the step, That's a little bit more difficult of a fix. There's a couple ways to attack that. The first one, when you have a step, would be to actually grind down the surface and create more of a gentle slope that it starts to experience if you can bring a grinder in and reduce the step. However, if you're not able to reduce the step and you're having a problem getting your air caster across that step, another simple fix would be to put a metal plate down over top of this, tape the sides down of the joint, and just use the metal, thin gauge metal plate as a transition point. Again, the more permanent though, you're going to be, solution would be to grind it and try to bring it back to a flush state. That's better for ongoing operations, but for temporary moves, a simple plate of steel would be able to transition a joint.